Our next topic is the law of large numbers. And what this says is, as an experiment is repeated over and over, the empirical probability of an event approaches the classical probability, or the true probability. So this is the sum of two dice experiment, and you'll see that we have the classical probability graphed right here. And the sum with the greatest probability is 7, because that has the greatest number of ways of achieving it. The sums with the lowest probability are 2 and 12, because there's only one way that you can get 2, and there's only one way that you can get 12. So we are going to be using this program on the calculator to simulate the rolling of dice. And if you don't have this program, that's okay, because I won't ask a question like this on the test or the homework, but this is a good example to go through. So this program has a roll dice simulation, and this is where it's going to graph the results, and you'll see that we have 2 through 12 here. So I'm going to roll 2 dice 10 times, and then this graphs the results. Notice it has not rolled a 4 or a 12. Now I'm going to roll 2 dice 10 more times for a total of 20, and this is what the graph looks like now. And then 10 more times, and then 10 more times, and then another 10. And this is what our graph looks like. Notice that we still have not rolled a 12. So let's copy this graph on our paper, and it's going to look something like this. So it doesn't have to be perfect. And you'll notice that this graph really doesn't look like the classical probability. The classical probability has to be perfectly symmetrical. Next, I'm going to roll 50 more for a total of 100, and you'll notice that we finally have some 12s. So our graph looks something like this. Then 150, 200, 250, and 300. And our graph looks like this. So still not perfectly symmetrical. It is getting closer though. And it is important to note that your graph of 300 may look totally different from my graph of 300. Now again, looking at the law of large numbers, as the experiment is repeated over and over, the empirical probability should approach the classical probability. So it should be looking like this. And I went up to 1,500 rolls, and it does look pretty close.